right, this is Unit 6, Lesson 1. This is covering Chapter 6.1 in the textbook. We are starting our unit on systems of equations. All right, so a system of linear equations is a set of two or more linear equations containing two or more variables. A solution of a system of linear equations with two variables is an ordered pair. What's an ordered pair? An ordered pair is x comma y that satisfies each equation in the system. So the ordered pair has to work for both equations. So if an ordered pair is a solution, it will make both equations true. All right, we are only going to be dealing with systems where there are two equations and two variables. Okay, you don't have to worry about more than that. So it says identifying solutions of a system algebraically. So given the following system, so what's the system? This is the system. You see we have two linear equations, okay? So these two things, that's the system right there, two linear functions. Determine if the ordered pair is the solution. So in order to do this, I need to plug in this point to both equations, all right? So first I'm going to do it for the first one. So x, what is x? X is 4. So 4 plus 2 times 1 equals 6. Is that true? 4 plus 2 does in fact equal 6. So it works for this guy. Now we have to check to see if it works for that one. All right, so x minus y, what is x? X is 4. Minus y, what is y? 1 equals 3. That is also true, okay? So because this ordered pair works for both equations, that means that that is the solution. So the solution has to work for both equations. Now let's see what it looks like graphically. So we're going to graph these two functions. So I'm going to go back to my purple. So I need to graph x. Why does it do that? Nope, cancel that. Okay. Go back to the skinny pin. All right, so x plus 2y equals 6. So let's go ahead and solve for y. So I'm going to subtract x from both sides. You should be able to do this on your own. Maybe pause the video and do the work without me doing it for you. Divide by 2. So y equals 6 over 2 is 3. Now what's in front of this x? There's an imaginary 1. So this is negative 1 over 2. So minus 1 over 2x. So that's one of the lines that I'm going to graph. The other line is the green line. So let me do that one up here. So this is x minus y equals 3, not 6. X minus y equals 3. So I'm going to subtract x from both sides. So negative y, don't forget this negative sign, equals 3 minus x. Divide, what am I dividing by? Not y, I'm not dividing by y. Dividing by a negative 1. So y equals negative 3, because 3 divided by negative 1 is negative 3, plus x, because a negative 1, that's a 1 in front of the x, divided by negative 1 is a positive x. So those are my two equations that I'm graphing. So I'm going to graph the green one first since I have the green pen out. So I'm going to start at negative 3, so 1, 2, 3. And my slope is positive 1, so I'm going to move up 1 over 1. Up 1 over 1, up 1 over 1. Keep going. This one's pretty easy. We're going to have a lot of dots here. All right, I'm going to go down this way also. Always double check that your line is going the right way. Is that a positive slope? Yes, it's going up, so that is correct. Okay, and then I want to go ahead and connect my dots. Okay, this is not an inequality. This is a regular linear function, so it is a straight line. All right, now I'm going to do the purple. So what is my slope? My slope is negative 1/2. My y-intercept is 3. So I'm going to go up here to 3. 1, 2, 3. And then I'm going to go down 1 over 2. It's got to be going like this. So down 1 over 2, down 1 over 2. Oh, look at that. down 1 over 2. Okay, or I can go up 1 and to the left 2. Up 1 and to the left 2. Again, I need a line there. So look what happens with these two linear equations. What do we see? We see that they have an intersection right here. Where is the intersection? Well, what do you know? It's at 4, 1. Why? Because that is the solution. Okay, so this system of linear equations has one solution. This is the only place where these two equations have the same ordered pair. So the solution for 1 represents the point of intersection. All right. So this system has one solution or point of intersection. A system may have none or infinitely many. Okay, and we're going to take a look at what that would look like. Okay, so when you have two equations that cross, that intersect somewhere, the point of intersection is the solution. There can only be one solution in this scenario. Only one solution. All right, let's look at the next page. A system with no solution will occur when the lines are parallel. Parallel lines have the same what? They have the same slope. Okay, so if we have two lines that are parallel, they have the same slope, that means they never cross. So what does that mean? That means they never cross, they don't have a solution. Because why? What's the solution? The solution is the point of intersection. So let's look at this example. Now this one's already in slope-intercept form. So let me go ahead and graph that. So I'm going to start at -6. And I'm going to move how? I'm going to move up 1 over 2. It's a positive slope. Up 1 over 2, up 1 over 2. Up 1 over 2. All right. I'm going to leave that like it is for now. I'm going to mark that red. And I'm going to do this guy in blue. Okay, now this guy needs to be rewritten. 2x minus 4y equals 8. I want you to pause the video and rewrite this one on your own. Get the y by itself. Pause the video and do it. Seriously, pause the video and do it. All right, so you should have gotten a minus 2x here, a minus 2x. Remember, this is a -4, so we're going to bring down a -4y equals 8 minus 2x. Divide by -4. So y equals, what's 8 divided by -4? -2. What's -2 over -4? Well, I know it's going to be a positive. What's 2 over 4? Well, it's the same as 1/2 x. So notice what happens here. What's the slope here? 1/2. What's the slope here? 1/2. So what does this look like? Starting at -2, going up 1 over 2. Up 1 over 2, just like we did with the other one. Okay, so these are parallel lines. They're never going to cross. I don't care how far you go with this. It is never, ever going to cross. The blue will never cross the red. So because they have the same slope, there is no solution here. There's no point of intersection. All right, and then lastly, a system with many solutions or infinitely many solutions will occur when the lines are exactly the same. So I'll do this one in red. I'm going to go ahead and start it over here. 6x plus 3y equals 12. Again, you should be able to do this on your own. So you can pause the video and then check your work. So I'm going to let you do that. And then this guy, okay, that one's already in slope-intercept form. So I'm going to go ahead and graph him. Don't forget, you're supposed to be rewriting this. So if you haven't paused and done that, do that now. So I'm going to go start at 4. And I'm going to move down 2 over 1, down 2 over 1, down 2 over 1. Again, checking my slope that it's actually negative. If I go up 2, I have to make sure I go to the left 1. All right, so that's your blue line. Well, what about the red line? Well, what happens here when I rewrite this is that it turns out to be the exact same equation. It has the exact same slope and it has the exact same y-intercept. Y equals 4 minus 2x. That is the same as negative 2x plus 4. Okay, you need to know that. You need to know that you can rewrite this, but you just have to make sure that the negative sign is still in front of the 2, which here it is. So when I graph this, it's going to overlap. It's literally going to be the exact same line. Now, if I would have given you this and this, it probably would have been really obvious, but I didn't. Notice that this equation was in standard form. That's how it's going to happen most of the time, is that one of them or both of them may be in standard form, and you have to make sure you put them in slope-intercept to see what they're going to look like on the graph. Okay, so the answer here is infinitely many solutions. So that is how you solve a system by graphing. You graph the lines and you see what happens. Are they the same exact line? Then it's infinitely many. Are they parallel lines? Then there is no solution. Or do they cross somewhere? Do they have a point of intersection? If they have a point of intersection, then that is your solution. And you can always plug that intersection back into both equations to double check that it is true, that it works. All right, see you in class.